Alright guys, so now we are going to talk about the section 4.4, lecture 4.4, graphs of the secant and cosecant functions. So to graph these functions, we need to remember perfectly well the trigonometric circle value function. And then we are going to work right now on the graph of sec of x, sec of the angle x, which is equal to 1 over cosinus of the angle x. So what do we do to do that? First of all, let's imagine that we want first work on the graphing cosinus over x. Well, if I want to graph cosinus of the angle x, cosinus over x will be equal to 0 if the angle x is equal to, if the angle, which is in that case x, is equal to pi over 2. So I know that when it's equal pi over 2, I'm supposed to have a 0. I know when x equals 0, cosinus over x will be equal to 1 when I will have the value of x equal to 0 or x equal to pi. I would like to add also 3 pi over 2 will make also the value of the cosinus equal to 0. So mainly what I have is, if I had to graph, and at pi I will add -1, 0, and then at 2 pi all will be also at 1. So mainly what I will have is this. This, and then pi over 2, negative pi over 2. Then I will go to pi, I will be at 1, and then 3 pi over 2 will be 0. And then it will be at 1 again at 2 pi. Okay, so this would be the representation of cosinus. Now, because cosinus x. Now, because I'm looking at sec of the angle x, which is 1 over cosinus x, you realize that cosinus x is on the denominator, which means cosinus x cannot be equal to 0. Cosinus x cannot be equal to, cosinus of the angle x cannot be equal to 0. Mathematically will be cosinus x cannot be equal to 0. So what does that mean? That means that at x equal pi over 2 and at x equal 3 pi over 2, x pi over 2 and x equal 3 pi over 2, if I want to graph the sec, I will have a vertical asymptote by symmetric effect of symmetry of my graph, but I know also that cosinus x could be equal to 0 if I was going counterclockwise with my trigonometric circle. And so at x equal minus pi over 2 and x equal negative 3 pi over 2, I will have vertical asymptote. And then it's super simple. What you need to remember is when you know the shape of your cosinus, to define the shape of your sec, you will just have to do this. And that will be the shape of your cosec. Now, if you take a look at the domain will be all real number except the multiple of pi over 2. So the domain will be all numbers except the multiple of pi divided by 2. On the other end, the range is from minus infinity to -1, bracket, union 1 plus infinity. Okay? If you look at the period is 2 pi. 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 Okay, so the period is 2 pi, the graph is discontinuous. Again, you don't really need to remember that. There are no intercepts with the x-axis, and that is because we are dealing with a fraction. And so the denominator cannot be equal to 0. Please try to look over that and try to remember that. Now, it's the same idea for sinus x and a cosec. So what I want to do is first graph sinus x. If I want to graph sinus x, so if I have sinus x, well, sinus x will be equal to 0 when the value of x will be equal to 0, pi, or 2 pi. And sinus x will be equal to 1 for x equal pi over 2 for the angle. And sinus of the angle x will be equal to -1 when the angle equal to 3 pi over 2. So if I want to graph this function sinus x first, I don't think I wrote right here, so I'm just going to write in red if you don't mind. I'm sorry for the back and forth, but in red we have the sec of x, okay? So on this one, in blue, I'm going to put x equals 0. I got the sinus equals 0, x equal pi, and x equal 2 pi. I got 0. I could definitely, if I go clockwise, x equal negative pi, I have also a 0, and x equal negative 2 pi, I have also sinus equals 0. Then I will have for x equal pi over 2, I will have the sinus equal 1. So for x equal pi over 2, I will have the sinus equal 1. For x equal 3 pi over 2, I will have the sinus equal to -1. And then for x equal negative pi over 2, I will have -1. And when x equal negative 3 pi over 2, I will have +1. So if I have to graph the sinus, this is what I have. This is sinus x. And to graph 1 over cosec, same idea than previously, I need to realize first of all that I have 1 over sinus, and sinus cannot be equal to 0. So therefore, that means that at x equals 0, I'm going to have a vertical asymptote. At x equal pi, I'm going to have a vertical asymptote. At x equal 2 pi, same thing. X equal negative pi, same thing. And x equal negative 2 pi, same idea. And then it's pretty simple, because if I want to graph cosec, I just need to do this. Okay? Obviously, you can always use your calculator to graph that. The period is 2 pi. If you look at the period, okay, if you look at the period, you will have a period equal 2 pi. You can definitely see that the graph is discontinuous at an integer or multiply of pi. There is no intercept. The graph has no amplitude since it goes to plus minus infinity. The graph has local extrema, plus or minus 1, at odd multiple of pi over 2. All of this stuff, it's something that you can define by yourself when you have the graph in front of you, and obviously finding the graph of cosec of the angle x is very simple. So I will let you read this. It's about, note that since the secant function is the reciprocal of the cosine, and the same thing for the cosec, and is the reciprocal of the sine function. And let's try to practice a little bit. So we have to graph the 3 sec of 2x. So in this practice number 1, 3 sec 2x, same idea. First of all, let's imagine that we have 3 cosinus 2x. Cosinus 2x equal to 0. That gives you x equal pi over 4 or x equal 3 pi over 4, following the same methodology that we've used in this chapter 4. We're doing exactly the same thing to find the value of the angle would make the cosinus of the angle 2x equal 1. Each of these values are defined first for y equals 0 and the other one for y equals 3. So in blue, I have the cosinus 3 cosinus 2x, and in red, I have the reciprocal, so 3 sec of 2x, which is 3 over cosinus 2x. And when I use the calculator, I'm supposed to find this, which is exactly the same thing that I found. So now you are going to graph the equation y equal 1 over 2 cosec of the angle x plus pi over 4. The angle is x plus pi over 4. So first, graph y equal 1 half of sinus of the angle x plus pi over 4. Then mark the vertical asymptote. As you know that the sinus cannot be equal to 0. So the sinus of the angle x plus pi over 4 cannot be equal to 0 in the expression of the cosec. And then you will be able to graph the cosec of 1 half of cosec of x plus pi over 4 very quickly, very easily. I didn't use my calculator to show you the graph, but that's okay. On this graph right here, same idea. Graph sinus x, graph cosinus x, then you will be able to graph the sinus x plus cosinus x. You are supposed to find something like that. So please, when you are going to graph, you are supposed to have on this last part right here the same thing, following the same methodology. Okay, guys? So I think we are at the end. Things should be pretty easy. What I could add, because I have 3 more minutes, I'm going to maybe say this. For the step number 2, graphing the vertical asymptote, you know that the vertical asymptote will be defined when your denominator, which is in that case sinus x plus pi over 4, will be equal to 0, because you know it cannot be equal to 0. And so that defines when your angle, which is x plus pi over 4, equal to 0, when x plus pi over 4 equal pi, or when x plus pi over 4 equal 2 pi. That means that you will have a vertical asymptote at x equal negative pi over 4. You will have an asymptote at x equal pi minus pi over 4, which is 3 pi over 4. And you will have another vertical asymptote at x equal 2 pi minus pi over 4, which is going to be 7 pi over 4. So if you have to change the scale, please do it. Obviously, because I'm going to decide this is going to be pi over 4. Therefore, this is going to be negative pi over 4. And 3 pi over 4 is going to be right there. 3 pi over 4. And then I'm supposed to have 7 pi over 4, which is way up here. Okay? So maybe the one I'm looking for might not be okay. So you may want to do another one. Actually, you may want to keep what you have right now, because pi over 4 is right here. So you know that you're going to have a negative pi over 4 is going to be right there. So you know that you're going to have at negative pi over 4 a vertical asymptote. I think at least it's probably the best way for you to do it. Then you're at 3 pi over 4, which is going to be right there. And then 4 pi, 5 pi, 6 pi, 7 pi over 4, you have another one right here. And then you graph, I let you do the other one. On this side right here, I'll let you write the vertical asymptote. And then once you have your vertical asymptote, because you have graphed the 1/2 of sinus x plus pi over 4, you will be able to graph the expression of y equal 1/2 of cosec of the angle x plus pi over 4. Alright guys, have a good day and see you in class.